Hello everyone, it's indeed inspiring to see you back again, and we are here in this Business Analyst series. We are going to help you with step-by-step journey to learn and develop your skills as a business analyst. Here, you will learn a lot about how to interact with client, how to capture the user stories, how to document them and produce BRDs and SRS, how you can do the data modeling part, UML modeling, software methodologies, Agile, Scrum and DevOps, so many and so much things to learn. So I insist you to go through this particular series and get an advantage on Business Analyst.
I would like to move towards the UML diagram, which we had discussed last time, and we will continue with that. So we had discussed two examples. One was use case example, and another was an activity diagram. So we will have a good discussion on UML today, UML diagrams. So UML diagrams. Okay, so UML stands for UML, Unified Modeling Language. Unified Modeling Language. And why this particular language is there? The first reason is that visual description can better explain than text. So that is one thing. And second thing is standardization. Standardization of the so standardization of the documentation. So unified modeling language, the purpose is that we need to have visual description is better, we all know. And at the same time, we need to have some standardization so that if you are visiting any other company, you are basically getting a chance. So at that particular time also, you should be able to understand and you should be able to figure out that what a visual chart is trying to say. So same notations should be there and same kind of drawings should be there. The shape should have same meaning. So that is basically the purpose why we have UML. Now we had discussed the types. So types basically it has structural and second one is behavioral or functional. So structural and behavioral, two types of diagrams are there. And in total, if we see that there are 10 to 13 diagrams which are very much popular and which are very much commonly being used. One by one, we will see them one by one. So under structural diagram, so I'll say structural, structural. So we have class diagram. So class diagram is structural diagram. Now, if we talk about structural diagram, they basically show the components like what it consists of. So we had discussed earlier also. So they basically contains what is inside that particular software or process, what is inside that. It talks about the components. So if we see that we have diagrams like class diagrams where we have classes, we have objects, then we have PACKAGES packages, then we have COMPONENTS components. So classes, objects, packages, components, these are something which are there inside the structural diagram. Then coming to the behavioral one. So behavioral will have some sequence, activity, state machine, like changing from one state to another state. So these kind of things would be there in case of a behavioral diagram. So let's start with one of the diagrams under a structural one, which is called as class diagram. So now these class diagrams, yes, class diagrams. So like this comes from the concept of real world entities. Like in real world, how do we see things? So similar way, this particular structural diagrams comes from real world. For example, let's say I have a mobile. So if I talk about this particular mobile, in that particular case, like if you see that this is a mobile. So if this mobile, I want to describe about it, so I can tell that like this mobile has got a cover, this mobile has got the screen is there, okay. Then it has got some buttons over here. Here also some buttons are there. Then it has got some input jacks for power and so only for power is there, multi-purpose is there, for audio also we can use. So we can see that I'm able to describe this particular mobile with the physical properties this mobile is having. So I explained all the physical properties. Okay. So, and then the color of the mobile. So all these things basically are the physical properties. But as soon as we start talking about that, what can be done with this particular mobile? Okay, so I can make a call and I can I can make a call to anybody and I can talk to that particular person. So this calling is a functionality of this particular mobile. Secondly, if I say that I can like put on the screen, I can put the password and the it will get unlocked. So that is another function. Then if I press this particular button, then the screen is going to get off. So that is another function. Then if I put this button, it will put on and put off the mobile's silent mode. Like silent mode will be put off or silent mode would be put on. So that is something which will happen. So if we see that this mobile is a real-time object, and in this particular real-time object, I'm able to operate with this particular mobile. How do I do that? I do with the help of the components which are present inside this particular mobile. Okay. So if I want to categorize these two things, one is basically the component, the structure of it, and second is the functionality of the same mobile. Once again, I'm repeating, if I want to basically classify everything into two parts, then one thing is, which is basically the structure, the composition part, like what this mobile is made up of, the composition part of this particular mobile, and secondly, the behaviors of this mobile. Now understand, take this mobile as a project, and if you want to redesign a mobile, then you'll have to keep these two things in mind. That one is the structure part, that what all structures would be there, and second is the functional part, like how this mobile behaves. So if I talk about a class diagram, so in the class diagram, if you see what happens, it basically talks about structure only. Okay, it talks about structure. So I will show you also that how a class diagram needs to be drawn. So now, if you want to create a class diagram, so I will inform you about the components, what all components are there inside a class diagram. Before going into that, just now I gave example, like one example I gave, and this example was of um, a mobile. Okay, so how a mobile has got some features. So similar way, let us basically try to have some more examples. Let's say I have um, a watch, okay, or maybe something else. Let's talk about a lock is there. So if you have a lock, in that particular case, the lock has got some components. The components are like the lock is having uh, the metallic part, and that hook is there, which we basically pull out and push, and then we have a key. Then basically some internal mechanism is there. So these are the structural part of that particular lock. Okay, and secondly, we have a behavioral part. So behavioral part basically means that you can put the keys, and you can basically lock, and you can unlock that particular lock. So lock and unlock are basically the properties or behaviors of the lock. So anything and everything you have around, you can just try to see that anything and everything you have in your surrounding can have some structural components, and they can have some behavioral component. Okay, so class diagram is coming under structural, so it will only deal with the structure, it won't deal with the behavior. So now in class diagram, what exactly we will do, we will create the classes. Okay, we will have the classes created. And to create the class, I will have a box, something like this. Okay, so this box I will create, and let me give it a style as yeah, this way. So now this is a class, but it's just a simple box. And if you really want it to be a proper class, then you will have to create one compartment like this, and you will have to create another compartment, and this another compartment would be coming here, and this compartment would be uh, representing the methods. So yes, I'll explain about that. So this is another compartment. So total 3 compartments we will have. So you can see that 3 compartments we have. Okay. So the first compartment basically is class name. CLASS, class NAME, name, class name. And I'll just left align everything. Okay. The second one, if you see this one. So this second one is the data members. And the third one, if you see, that is the member method. So third one is the member method. MEMPER, member, METHODS methods. Okay. So now you need to understand that what is a class name, what is data member, and what is member method. So you need to understand all these things. I'll explain about that. Before that, let me have a copy of it. So we can have one class, we can have another class, like we can have multiple classes. And now these classes will have a relationship. Okay. So what kind of relationship these classes will have? For example, if I say that this way, okay, so let me just bold it. So you can see that there is a class which has got relationship with the other one, and there is an arrow also. So arrow represents something. For example, let's say we have a car, and car has got some accessories, maybe music system. Okay, so a car, this class would be car. I'll just redraw it for taking this particular example. So yes, here you can see. So this class would be car class, car. Okay, and this would be the music system. Why? Because one car class is there, which is having a music system. So from this arrow to this arrow, okay. So that arrow represents okay, a kind of relationship. So what kind of relationship do we have here? Let me put that also in place. So the kind of relationship which we have is like one car, okay, one car can have how many music systems? So ideally, the standard is only one. Yes, only one music system can be there. So I will write in this particular arrow, one car can have one music system. Okay, so this we call as a relationship, one to one relationship. So this is one to one relationship representation. Very similar way, let me talk about relationship now. And this is one, that is one to one relationship, and I'll just make another copy of it. So this is one to one relationship, one, then two, one, RELA relationship. Okay, one to one relationship. Then this one is, let's say if I put over here star. Okay, star basically means many. Asterisk symbol basically means many. Okay, so in this particular case, if I say this is one to many relationship. Okay, one to many relationship. I'll give examples also. I'll give examples for that. So in case of one to many, here I can see that one person, so this is person class, and this is songs class. So one person can, or maybe this is singer class, SINGR, singer class, and that is songs class. So one singer can sing so many songs. So it's a relationship that is one to many. Okay. Originally, if I see that original singer, so for one song, there'll be one original singer. Okay. So one singer can have sung multiple songs. So what is the kind of relationship? One to many. One singer singing many. Okay. Then we have many to one. like this will be many and this will be one. So many to one relationship. So many to one relationship. So this is MANY many, two, and ONE one relationship. So many to one relationship, what is the example? So here BANK bank, ACCOUNT bank account, and this is PERSON person or customer. So many bank accounts belong to a single customer. Is it true? The answer is yes. Many bank accounts can belong to a single customer. One customer can hold more than one bank accounts, and this is a true relationship. So many to one relationship. And then we will have the one more, and this one would be many to many relationship. So many to one, and then many to MANY many. So many to many relationship. So in this particular case, we will have let's say, so something which is multiple in number and can belong to many people. So this would be, for example, I can have subject, SUBJECT subject, and here students. And this also I'll put asterisk. So here you can see that subject and students. One student can have multiple subjects. So one student can study multiple subjects, and one subject can be studied by many students. So from subject to student also, like one subject can be studied by multiple students, and similar way one student can have multiple subjects. So in simple words, many students study many subjects. Okay, so many students study many subjects because one student studies multiple subjects, and one subject can be studied by multiple students. So therefore, multiple subjects are being studied by multiple students. So this is the meaning of this particular relationship, many to many relationship. So in a class diagram, we show these relationships also, and that gives a sense that okay, in the system what kind of mechanism would be. So for example, if you want to log in and you want to post something, so to your post, who will be able to edit that particular post if there is an edit functionality to be implemented? Only you can do that. No other user can basically touch or do any kind of edits to your post. So therefore, you are there and your post is there. That's it. So this is one-to-one relationship, user and post, one-to-one relationship. We cannot have it one to many, like one user can uh, for editing, basically editing functionality. So whenever we are thinking of something like this, we need to think of these functionalities, that is one to one, many to many, many to one, one to many. We need to think and understand about these functionalities. Now moving further and trying to understand more about it. So let me have a class and let me take it here. So here what we will do, uh, like this is a class. Now many times what happens, a class can have some components which are subclasses, which we call as subclasses. Okay, so what can be subclass? A subclass could be, for example, now let's say we have made some order. So whenever we are making an order, so at that particular time what happens, like if it is a small item, let's say if it is a small item like maybe you ordered biryani or something, okay, or maybe a thali you ordered. So if it is a small order, it's fine. Secondly, sometimes there are large orders, party orders, okay, bulk, in bulk. So like orders can have type. So what I can have is I can have two classes, different classes. Yeah, so you can see that we have two different classes now, and these two different classes, they represent the order type. Okay, so for everything we have special arrows, like here we have a special arrow. I'll try to have it. Let me try with this. We have software, and multiple softwares are there for UML diagrams. So they actually help us with all the shapes. So if I basically make it like this, and design, okay, and a format, shape outline, and weight. Okay, let me increase the weight, and okay. Hmm. Okay. Okay, so here we have different arrows over here. So it's a hollow arrow, which I actually need, a transparent arrow. So arrow type. Okay, so that type of arrow is not here. No worries, no problem. So it needs to be, this part needs to be, if you see, this part needs to be empty from inside. Okay, so that is something I actually need, I want. Okay, so in this particular case, we don't have, no worries, that's not a problem. Okay, so something like this, we require, let's say there's no fill in the shape, and like this. Yeah, so this is the kind of thing we actually require. Okay, this is a kind of thing. So I'll just put it over here just to have a right, correct representation of it. So this is the arrow. Okay, and similar arrow would be coming up from the other side. Okay, so this is one arrow. Let me just put it over here so that we have some space for the arrow coming from the other side. So yeah, so from here also there will be one arrow which is coming in, and yes, let me put it over here. Okay, and let me have this particular shape superimposed this way. So this is a kind of relationship, and what kind of relationship we have? Like, this is a normal order. Let me give the description also. Normal order, and this is special order. SPECIAL, special order. Okay, so we have order, we have normal order, and we have special order. Okay, and now if you see that, this is the parent class. Okay, or super class, we call it as a super class. So SUPER, super, CLASS, class. And if it is super class, then what are these two? They are subclasses. These are sub, SUB, subclass, and this is also subclass. So one is superclass, and the two other are, they are subclasses. This particular concept is called as, like, from here, from the subclasses, we are moving towards the superclass. So this is called as uh, generalization. So I'll draw an arrow over here. Okay, so because if we go like this from top to bottom, okay, so if we go like this is one way, and the other way would be if we go opposite. Okay, so yeah, so if we go in opposite direction, let me put it over here. Okay, so this particular thing, let me put it into orange. This is called as from top to bottom, like from order, if we are splitting. So that is called as specialization, because from generic, we are going towards specific things. Okay, so SPECIALIZATN, specialization. Okay, and the vice versa, if you see on this particular side, this is basically known as generalization. GENERALI, said a generalization. Okay, so specialization and generalization. Generalization, because we have certain specific things and we are making it more generic. Okay, therefore it is known as generalization. So this is what is the concept. Okay, so let me again give it a different color, and let me give these two things a different color so that they look same. Okay, so they could be green. Yes, so this is a concept. Like one is specialization concept and another one is generalization concept. So these are the concepts which are being used while drawing a class diagram, and there are certain more like we have something called as composition. Uh, so we'll discuss them also. Now let us try to have few examples of class diagram. So the system which we were discussing, that we need to have a portal where the leads database can be managed. Okay, so now while creating this particular system, we need to identify that what all classes would be there. We need to understand and identify that what all classes would be there. So now what all classes would be there, how to identify that. So in order to identify that what all classes would be there, let's create a list of it. So yes, CRM. Okay, CLASSES, classes. So what all classes? So let's say lead itself is a class. Okay, lead is a class. Then what else would be there? One is lead. Another is executives, like the office executives would be there. Okay, employees basically, or I can write employees. Then what else could be there? Let's say then one, services, like what all services the company is giving. So that class would be there. So we should have a list of services also, that these are the services which company is offering. Okay, what else could be there as a class? So lead is there, employees is there. Then if lead basically tries to take up some service, then what is going to happen? The service is going to get ordered. So we need to maintain some order in a particular class. Whenever order happens, then what happens? Then basically some transaction happens. So transaction will happen because of invoice. So there will be one invoice class, billing or invoice class would be there. What else could be there? Dispatchment class could be there. And then whosoever is delivering the packets, so some more classes can be there. Okay, and yes, so if it is let's say based on some product, then we can have inventory also. So inventory would also be there. So this is how we need to list all the classes we need to list. This is the step number one. Now the next step is that once we have all the classes listed, so as I said, any real-time object, like lead is a real-time entity, it exists. Employee is a real-time entity. Service is not physical component, but it's also an entity. Then order is there, invoice is there. Okay, so for all of them, the next step is that we need to write two things for all of them. One is the kind of composition it is having, and second, the kind of functionality behaviors they are associated with. So with all of them, we'll have to write. So starting with the customer part or lead part. So lead or customer, customer, customer. So two parts we will write, and let me have the layout like this. Composition, technically we call them as in a class data members, and we can have member methods here. Okay, functions. So lead a customer. So here, name of the customer, email of the customer, mobile number, then location, then what else can we have? Okay, address. So with location, I'll write here only address address. Then yes. So as per the system demand, like for example, we can have service ID or something, like for which service that particular person inquired. So we need to have a detail of that also, like which service that person inquired. So these are the just structural components, like they're not talking about the behaviors, they are just structures or composition part. Now behaviors, what a customer can do: customer can make a call, customer can write an email, customer can place order, customer can CNCL, cancel order, place reviews, so review maybe product or services. Yes. So update info, COMPLAINT, complaints, exactly. Customer can do complaints also. So these are few functions. Now understand, we need to write all the functions. Like it is not like we have to write few, we have to write all. So when we are documenting, this is for example we have written few, but when we are documenting, we need to write all the functions and all the data members, that is composition of that particular entity. So this was only for one. Similar way, we have to write for each one of them employees. So let us see that what employees can have. So employees, composition. So uh, employee again can have name, email, then mobile number. Then we can have DSIG, designation, then date of birth. Okay, then DPART, department. So many things which are related to an employee composition. Okay, now what would be the behavior part, functions part? So customer, sorry, employee. So whatever department is there, based upon that particular department, he will have his own responsibilities. Okay, but let's say the way we are talking, let's say he's working for yeah, sales, let's example. Okay, so if he's working for sales, in that particular case, what is going to happen? He will have to make calls. Okay, he'll have
Take
to
calls.
write emails. So this is how that particular employee needs to work. So we need to create this much of detail into a document, and then we have to go for that particular yes, so that particular uh, diagram creation part, once we are done with these detailing, so that we can put them in the diagram. Yeah, so when you're putting the same thing into a class, so employees is the class, so I'll write here EMPLOYES, employees, and here I'll be writing the names, like mm, all these things. I'll just take them from here, so they will come over here, and then the functions are going to come over here. Okay, so this is how it needs to be. Like this is how a class diagram is created. So for all the classes, like first you can have a rough note, and once they are final, you can put them like this. Okay, in this particular case. Now let me show you something. Um, this is class diagram we discussed. Now let's go to the browser, and here, like there are different softwares. One software name is STAR star UML, star UML download. Okay, enter. So this is star UML software which helps us to create such diagrams. Okay, so it is asking for which Windows and all. So I'll download for Windows star UML, and here, like we have some online also, Lucid chart. So here you can see Lucid chart. So this Lucid chart, here also you can create a free account, and then you can basically create diagrams. This is again like everything has got a free version, and again a paid version. So Lucid chart is intelligent diagramming application that helps us to create diagrams using Yes. So here, three editable lucid chart documents, 60 shapes per lucid chart document, 100 templates, basic visual activities. So only this much they give for creating the UML diagrams if you go for free. So I'll be going for free shortly as of now, and you can create a login with your Google account. So let us do the login. Okay. It's taking, yeah. So now here you can see. So it is not only for UML, but it is for lot of whatever diagrammatic representations are there, you can do with Lucid. So here it is asking like if you want to start up with an example or if you want to create a blank one. So I'll click on blank one and start diagramming. Okay, so open the shape library manager by pressing the M key. Okay, shortcuts, it's telling. It's loaded now. Here you can see it is loaded. Okay. So this is one way where you can basically do the setup, the lucid charts. What's your role, some surveys and all. So let's say I'll put this way. Yeah. Hmm. So which business admin? Uh, okay, flow charts. Okay, let's go for flow charts template. Okay. Yes. So here diagrams are there. Technical system diagrams are there, and design UI. Okay. Education. Class diagram. So here you can see this is UML class diagram, and I will insert the template for a class diagram over here. So okay, yeah. So here's the template. Hmm. So let me just reduce. So here you can see this is class diagram. Okay, already it has created the templates. If it's a bit complex, you can start with simple ones. So this is classes, the first upper box. Second box we call it as attributes, data members. Third is operations, functions part. So these are different classes, and we can now start editing it, and we can keep on putting the like class relationship we want. That way we can put it. So this is one, but as it said that it will only allow you three charts to edit it. So you can work on those three only, but for practice purpose it is good enough. So you can click on it and you can edit, like you can just click on it and you can edit the class name. So we had like so here like employees. Now employees class is there. So what is the relationship between other classes? So if there is no relationship, you can click and you can delete that particular thing. Okay, that there is no relation. You can click and delete that particular thing. Okay, if there is no relation, you can do it like this. Fine. And then employees. So I basically will remove. I would prefer to start from scratch and taking one class. So that's fine. So employees, now what employees is having that we need to write here inside. Now while writing inside, there is one problem. Okay, not a problem, like there is one addition. So you'll have to like sometimes we don't want to give access to all our things to everyone. Okay, so there is a limited access we have given to few people. Okay, if somebody else uses, we feel very much offended, like why did that person use it? Okay, so therefore here we have symbols, plus, minus, we have symbols. These particular symbols identify their yes. So these symbols will identify us that whether that particular thing is open and accessible to all, or whether it is restricted and it is a bit private to the class itself. It's a logical concept. Okay, so this is what is the meaning of that plus and minus. Plus basically means it is public and publicly available. Anyone can basically use it, call it. But if it is minus, it is private and only the class can use it. So therefore, that level of detailing has been done here, like, and that level of handling is there in programming languages. So these class diagrams can be used by any programmer using any kind of programming language. So anyone can use it. Okay. So they will have same representation. Coding wise, they will do a little different, but conceptualization will be same. Okay. So this is one option, and I hope my star UML is about to download. Okay, only a few seconds remaining. So star UML, you have to install it in your own machine. You have to install it. So once you install it at that particular time, you can start it. It is like a desktop application, and it gives multiple variants of um, yeah, different charts. Yes. So it's stuck in between. Okay, 0 bytes remaining. So I would prefer, yeah, it's done. So let's just have a setup of it. Yes, so I've started this setup. So you can also install it, and so that, like, further exploration we will do with that. Like initially I told in PowerPoint, then I'll continue with the other designs. So whatever possible options star UML is going to give us, we'll make use of that. If it is not giving some options, then we can switch to any other way. So you can see that it was so simple to install it, just a single click, and it got installed. And it says that this is unregistered version. So obviously, anybody would like to give us something to practice, but later on they would like us to basically buy it from them. So this is the area where we can draw, and on the right hand side we can see like class, interface, association. So these things are given. Whenever we have to create some diagram or something, we can go to file, and we can, so here from new we can create a new window. So already some window is opened. This window is opened, and this is main. Under main model we can add uh, so under this, close other diagrams, close all diagrams. So currently only one diagram space is opened over here. Here also there is no model yet created, so we'll have to do. So here you can see, if I click on model and right click, add diagram. So you can see class diagram, package, object, composite structure, component, deployment, use case diagram, sequence diagram, communication, timing. So I just told you that there are 10 to 13 very much famous and very much being used. So here you can see more than that, a number of diagrams are there. So class diagram we were creating. So if I click on class diagram, here you can see the components will come as class diagram on the left hand side. But if I try to change it, okay, so it was a class diagram and add. Okay, so add, I, it's okay. Hmm. So add diagram. So here if you see, so we have apart from class diagram, if you see, we have so many other diagrams over here. So if you want, it's a sequence diagram, you can click on it, and you can see that on the left hand side, all the options are changed. Like they are basically now coming from a sequence diagram. So we will step by step see all these things, that what is the purpose of these diagrams. And I hope everybody understands now that these are the diagrams which are like a language to the developer. When he sees them, these diagrams basically speak a lot, Instead of writing sentences, diagrams better speak up and clearly speak up.
If you like this video, please do share it with your friends and those who need it. And don't forget to press the bell icon and also subscribe to our channel so that you can get all the videos notifications readily in your account.